Hey everyone, we will now proceed to find out how do we obtain the area bounded by two curves. And this video is only for the H2 Math students. Alright, so area bounded by two curves is very simple. We just need to compute two different integrals, but also need to find a way to actually get us the area bounded by the two curves, because it's not as simple as addition or just subtraction. There's some thinking involved. So let's start with a very basic example. So let's have a curve of y equals to x squared, and then the line y equals to x. Okay, so it is x squared, this is just x. Okay, so area bounded by two curves. So first, what area are we going to find? So when we talk about the area bounded by two curves, right, the area must be closed, right? So it must not be an open area like from here, the one on the left, nor on the right, because there's no close, right? However, if you look at the area in the center, this overlooking shape, you realize that there's a close, right? So there is just a close here, and there's a closed loop here. And then we'll get this area in the center, which is the area that we want. So how do we compute this area, right? So first, let's think about this. What is the area that is possible? So use the skills that you have learned, all right? So let's make it simple. Let's consider with the very basic one, the area between the curve and the x-axis, right? So let's consider the graph x first. If you're gonna we already know that they're intersecting at this point, right? So that means your limits would be these 2 points as well. So let's consider it. So we have y equals to x, right? If you're gonna integrate, find the area between the curve and the x-axis, it will be this triangle here, right? So it will be this whole triangle here. However, instead of denoting this as a whole triangle, we'll split the areas into two. We want the area A, right? A, but then if we're going to integrate with respect to x, you'll get this area B as well. So how do we find a way to get rid of the area B? What do you notice about the area B? Is the area underneath the curve y equals to x squared from these 2 points, right? From the two intersection points, right? As such, what we know is that if the area underneath x squared is b, we just need to equate the area as integrating x from the intersection points minus away the area between underneath the curve y equals to x squared from the two intersection points as well, right? Because in the area underneath x from these two intersection points are a and b, and the area underneath x squared from these two intersection points is only b, but we only want a, right? So if x gives us a plus b and x squared gives us b, and we only want a, it's just a plus b minus b, right? So integrating x minus integrating x squared. So there we have it, the whole idea of getting the area, but we need to solve it, right? So first of all, find the limits, which is basically the two intersection points. So we equate x equals to x squared, right? Then we get x squared minus x equals to 0. Do your normal manipulation. X bracket x minus 1, and then we therefore have x equals to 0 or x equals to 1. So clearly we know that the lower point is 0, the upper point is 1. So we can then have integrating from 0 to 1 x dx minus away integrating 0 to 1 x squared dx. Simplifying, well, we can actually choose to integrate it from here directly, but this is also equals to integrating 0 to 1 x minus x squared dx. And therefore, if you apply the basic integration rules, you get x squared over 2 and x cubed over minus x cubed over 3. Put in your limits is half minus 1 over 3, because if you substitute in 0, it's just basically 0 throughout. You get 1 over 6 units squared. Alright, so that is the area bounded by the two different curves. So here's a technique, alright? First of all, try something first, alright? See whether x or y is better for you. In this case, you try out x, you realize if you integrate x first, you get a plus b, area a plus b. And now you just want to get rid of b, and you notice that getting rid of b involves integrating x squared. So that's how you should do it, alright? First, test out an area, see how many segments you have. In this case, you have two segments, A and B. and then proceed to find out how do you get rid of the extra segments. So let's consider another example, albeit a more complicated one. Let's say we have y equals to x minus 1, x plus 1, basically x squared minus 1, and again the graph y equals to x. So we know that a graph is something like this, okay? And then the same question applies, right? Find the area bounded by these two curves. So if x minus 1, x plus 1, so this minus 1, this is 1, and the same thing, y equals to x. Okay, it's x, this would be x minus 1, x plus 1. Alright, so we know that the area bounded by these two curves are this here, right? Okay, so we don't have to really mark that out. Then we have these two intersection points. We'll find the intersection points later, so not to worry about that. But for now, let's just figure out what we can do. So, actually this is quite complicated. So right now, we'll just figure out how do we get the area down here. So first, let's just choose an area to integrate first. Let's say we choose to integrate x first, right? To which variable? If you choose to integrate with respect to y, right, you notice you're not going to get anywhere, right? Because the area is on the horizontal, which is not part of the area that you want. So forget it, all right? Let's integrate with respect to x. So if we integrate with respect to x, what do we have? We'll get these areas, right? So you get A, you get the top part B, and then you get C. However, what do you not include here that is actually needed? Is this below bottom area D. So you only get A, B, and C, right? However, what happens is that you only want B. So you have additional A and C. And one more thing to take note is that the area of A that you got is actually a negative area. So something that you could consider doing is that if we integrate x from the two intersection points, it's basically B plus C minus A. Correct? So now you've done this, let's consider the other graph, right? Which is the quadratic graph. If we integrate from this point to this point for the quadratic graph, you get A, you get D, you also get C. The only thing is that if you integrate the quadratic graph, right? So let's say x squared minus 1, which is actually the exact quadratic graph. It's basically C, and you notice that A and D are both in the negative area. So you get minus A minus D. All right, but you only want B and D because that's the area you want, right? The actual area that you want are B plus D. So how do you get B plus D? So you have minus D here. So let's try, maybe let's take integrate x minus integrating x squared minus 1. What do you get? You get B plus C minus A minus away C minus A minus D, which will then give you B plus C minus C is 0, minus A minus minus A is 0, and therefore you can get B plus D. All right, so the area, ultimately the area, all right, is basically the intersection points x1 and x2, integrating x minus away integrating, dx minus away integrating x1, x2, x minus 1, x plus 1, dx. Okay, so I'm not going to solve this because it will require some long manipulation, because if you realize if you're going to solve for the intersection points, it's basically x equals to x squared minus 1. You get x squared minus x minus 1, which is, you know, kind of impossible to, it's kind of long to do it because you got to use the quadratic formula, which is again a very pain to do it. So usually they would ask you to, you know, not find the exact form but use a graphing calculator to do it. So yeah, this is the whole idea of how you can find the area between two different curves. One thing to take note is that, I repeat, how you do it is first find the areas that you need. So it's usually a closed loop. So in this case it's B and D, and then choose one to integrate first. Choose one of the graphs to integrate first, right? Between the two limits, which is the intersection point. So in this case, when you really integrate, you get B, you get C, you get minus A, then you miss out the D, right? Then you use it to find the other graph. And usually you add up together, right? Usually you add up together, you get the area that is left out, and you would be able to cancel out the extra areas at the end, just that you have to be careful of how you put the negative sign. All right, so yeah, there we have it. Find the area bounded by two different graphs.